Once again, thank you very much for making time for this webinar on mass structural engineering for timber. My name is Qaqambile Mangalaza. I'm from the National Housing Finance Corporation. I will be a facilitator this afternoon. Colleagues, just as a way of kickstart some ground rules, let me first and foremost ask everyone to be on mute. And I'm going to then ask Samantha to make sure that the session is being recorded for the benefit of people who may not be able to attend. And I may wish to ask the people who are not speakers at the time to actually switch off their videos. I guess at times it becomes difficult for connectivity to have everyone with their videos on. Colleagues, this webinar is hosted by the Demand Creation Working Group of the umbrella program, which is called Promotion of Wood in Construction. This program is led by the DTIC, and DTIC is leading this program with the support of some of the stakeholders. Colleagues, I have an agenda for this afternoon in front of me, and I'm not too sure if anyone has not seen it. Just to run through the agenda and to maybe introduce the speakers. Firstly, we've got a welcome note, and you would have noticed that I have not done any very big welcome and outlining any objectives or anything. We've got a very strong speaker today, Professor Krishna du Plessis from the University of Pretoria. She will be doing the opening remarks for us. She is from the Department of Architecture, the School of Built Environment within the University of Pretoria. After Prof. Krishna, we will then have specialist presentations. I think we've got 3 specialist presentations. The first one, we've got it from our architect who's very passionate about timber, Bram de Villiers from Earthworld Architects. He will give us a presentation. After that, we need to be listening to Stiffness van der Westhuizen from Zutari. You would know Zutari formerly as Orecon. He's also going to tell us about some of the structural characteristics of timber. After that, we will have Prof. Brand Wessels from the University of Stellenbosch. Also, he will take the discussion further. After that set of presentations, we will ask Dr. Skalk Grobler, Senior Lecturer, University of Pretoria in the Department of Engineering and Technology, to lead a panel discussion with the presenters, and the presenters will now be joined by Dr. Jennifer Murembe, who is from the Department of Human Settlements. He's got a set of questions to ask them. I'm happy I'm not one of those speakers, but we will listen very carefully from them. And then the last bit of it will be the closing remarks, which will be done by Roy Saudi, Executive Director, Sawmilling South Africa. Colleagues, without further ado, can I then ask Prof. Krishna du Plessis to give us opening remarks? Over to you, Prof.
Thank you, Prof. Q. So I'm going to be very short and sweet to give everybody an opportunity to engage with our speakers and to have a proper question and answer session at the end, or a debate at the end. So my role here is to welcome you on behalf of our sponsor, Sawmilling South Africa, and in partnership with the Department of Trade, Industry and Competition, the Department of Human Settlements, the National Housing Finance Corporation, and the Universities of Pretoria and Stellenbosch for this particular seminar. And this is the first of a series of webinars on the potential of timber construction in South Africa, where we will unpack a little bit some of the concerns and some of the questions that people have around the issues of timber, and particularly mass timber. So we are rapidly moving into the 3rd decade of the 21st century. It doesn't feel like that, but we are getting old. And in this century, we can see now that the world is very much facing 2 major crisis points. And the first is this existential crisis that's presented by climate change and biodiversity loss. And the second is the growing economic inequality and poverty that's made worse by changes in the world of work. And in South Africa, foremost in our thoughts should be the need to create economic opportunities for the 64% of our youth who remain unemployed with little hope for a better future. At the same time, the country is contributing more of its fair share in terms of carbon emissions, being the 12th largest carbon emitter on the planet, with a population that makes up only 0.76% of the total world population. So we really need to start looking at how we can address this in creative ways. And timber construction, I think, has the potential to address both these problems, reducing the carbon footprint of our construction materials while providing new opportunities for manufacturing and skills development. It's also an excellent gateway towards a future construction industry where most of our materials are bio-based, thereby reducing not just the carbon footprint of the industry, but also the negative impact of the extractive materials industries, and hopefully providing opportunities for restoring biodiversity and creating a healthier built environment. I applaud the DTIC in starting this initiative, and I hope that you will enjoy today's seminar. And with that, I hand you back over to our MC Brock Hugh to introduce our first speaker, Architect Bram de Villiers. Thank you very much.
Thanks very much, Prof, for setting the scene and for giving us those highlights and things to note. Bram, may I hand over to you and to lead us? Please share your presentation. Thank you.
Thanks. Thank you, Brock. I think I just want to.
Yeah, we can't see it right now. Yeah, it does appear. You can go, Bram. Thank you so much.
Okay, thanks, Brock, and thanks for the introduction. Sorry, it seems like it disappeared for a moment again. Just give me a second.
It is back. Thank you.
Okay, thank you, Brock, for the introduction. I think just to start off with, this webinars, we are trying to promote the use of timber construction, especially in mass timber construction. I hope this can serve as a platform for professionals to connect with manufacturers, construction managers, academics regarding the potential of timber construction, and that it can become a space where we share ideas and ways to promote timber construction in South Africa. I'm an architect. My practice here in Pretoria with Andre Ekstein and our team from Earthworld Architects has been involved in a number of timber structures over the years. And maybe this presentation just serves as a primer for discussing the possibilities and the challenges regarding timber construction. I think in the making of timber buildings, the process, just to briefly describe it, first part as architects is the conceptualization of these structures, then the architecture detailing and modeling of it. Then obviously we get the engineers involved and the engineering and the modeling of that. Sometimes it involves prototyping because we need to understand the specific joints and connections with timber. Then the pre-manufacturing part are normally off-site, and then the assembly and construction part, which happens on-site. I think in terms of timber buildings, the size of the construction is obviously playing a role, whether it's a single-story or multi-story building, the functional requirements, the complexity of the structure, and the complexity of the site plays an influence on the design of timber buildings. If we look at single-story buildings, I'll first just look at residential ones. I think the architectural design and modeling are fairly straightforward. The codes are familiar to most manufacturers and timber frame contractors. Most BCOs at local municipalities knows how to approve or assist in the approval of that, although it still remains a challenge. And the engineering design is fairly uncomplicated. Just an example of a single-story residential home here in Pretoria. I think from an architectural design and modeling perspective, I think three-dimensional software like Revit and ArchiCAD with BIM capabilities has brought a systems thinking approach to design of buildings and structure, and it's sort of imperative when we design these structures that we have this kind of software. I think these BIM models can be shared with manufacturers of products and contractors to help with the assembly and the construction from the concept stages of the project and for their expert input. Likewise, the BIM models can be shared with professional teams, especially the structural engineer, that can collaborate from the onset in design of the structure. The three-dimensional BIM models explored in the office and the different joints are in terms of the construction is explored, and then obviously pre-manufactured off-site and then assembled on-site. This is a double-story home here in Pretoria. It had a framed construction, a laminated laminated pine structure that the timber was purchased here in South Africa from White River sawmills and then assembled on site and then cladded with the imported large cladding. That's the top structure of the house. And this is some interior views of the construction. I think in terms of the tools the modern tools that are available to architects and engineers, we first have digital design tools, and that allows us to integrate with digital manufacturing tools, which creates a large potential for accurate construction of timber buildings. CNC machine, laser machines, all of these machines are available to prepare the product off-site. And I think in terms of parametric design, it gives us the ultimate flexibility with this modern technology to create really amazing structures. Similarly, in South Africa, I think the BIM tool, the BIM integrated tool, together with the architect, can produce drawings that can be manufactured by small SMMEs. And then we believe, and as I'll show you one example now, that it can be sort of assembled on site by fairly unskilled laborers, that can, so we can really make cut a complex building out of timber and then assemble it on site. When we move to larger scale single story buildings, the architectural design and modeling can get more complicated. The new codes in timber are quite unfamiliar to designers, and training for professionals in these codes has become critical. I think structural training programs by institutes and universities does not necessarily exist at the moment and needs to be developed. Most BCOs that's building control officers at local municipalities do not know how to approve or assist architects in approval of these plans for mass timber buildings. Similarly, engineering design requires a high level of expertise and understanding, and I think there's very little local engineers are trained in timber design, and very little local skills are available. In most cases, we have to look for assistance abroad. This project is at the University of Pretoria, the Future Africa campus, and the hub building was designed by our practice. It was manufactured off-site and then assembled on-site by a local contractor. This is just some of the components, and this is how the building was assembled on site together. So this is the off-site manufacturing process. 3 layers of 30mm imported birch ply was used to construct the structural portals for the building. They were then assembled on site through a process. And what was amazing about this building is that there was only 9 carpenters, a team of 9 carpenters involved in this process, and it was fairly unskilled labor that assembled the building. The testing of the structure on site, and then the completion of the structure, rendering a beautiful space with timber construction. If we now move to larger scale multi-story buildings, I think this is really the questions that we like to ask one another this afternoon. The architectural modeling and design are complicated, requires skilled architectural professionals to understand and employ the design. And again, I think there's a much needed postgraduate training for architectural professions by institutes and universities, and it needs to be developed. I think in cases like that, it is imperative that all consultants should be able to work in a BIM environment. It helps, especially because these buildings are fairly complicated and need. It's much easier solved within the computer than on-site sort of testing. The clients in this case don't necessarily always understand the implication and cost risk of these constructions. They tend to shy away from timber buildings in general. And I think there's opportunity here for short guideline documents for mass timber construction in South Africa that should be developed for clients to understand the potential of mass timber buildings in South Africa. Again, I think the building control officers at local municipalities needs to be trained. I know that we can do rational designs for structure and fire, but I think the BCIs need to understand the fundamentals and the codes for mass timber construction or mass timber buildings. I think as well in South Africa, there's very little engineering expertise around. It's just the nature of our building industry. For years, we have been training engineers to design in steel and concrete, because it is the preferred material for building. And so I think there's a huge gap in the training at universities to upskill our engineers to design for large-scale timber buildings. This is just a picture of a project that we are busy with for a University of Zululand. Again, the BIM model and the BIM protocol helps us to understand these buildings, and we can really take them apart and put them together in a computer, and we can share it with our consultant team to make the building. There's some plans and sections, and again the BIM model to sort of to understand the construction and to really test it and try and understand the way that the joints in the building are working are important. There's some renderings. So I'm rather going to leave you with a few questions, and then we can discuss it after that. I think first of all, we can discuss the codes that are in existence, especially the new CLT, cross-laminated timber code. Can it be used practically locally? And I would like to discuss the testing of components that was manufactured by the manufacturer. The engineering requirements, what are the type of software applications that are available to most engineers, companies use them to their full potential. The testing, which test facilities are available and do they function on the level that they should? Again, looking at CLT. And then the current hurdles in terms of South African context, testing again, and availability of structural engineers that can design timber buildings. And I think there's a huge role that academia and institutes can play in the training of our professionals. I think that's also important. And then coming to the local material suppliers, are the suppliers that can produce scale and quality, or is the only option to import mass timber components. At the moment, there's 1.5 manufacturers of CLT in South Africa, and I think there's a huge potential for growing that industry. Thank you very much.
Thank you very much, Bram. I must say it's very lifting to hear from somebody who practically does this on a daily basis, small scale up to big scale. The questions that you've raised at the end are, for me, a bit chilling. It shows the amount of work that as a country we still need to do, but I think we equal to the task. Thanks once again, Bram. Without wasting any more time, may I ask that we take forward this discussion to looking at the structural elements of the timber, the strength and everything. And I think Stephanos will take us through that, because there are a number of myths that are existing in our society. And I guess that's why we have so many people not demanding wood or timber as a building product. Some believe that it is weak, it doesn't have a structural strength, and I think Stephanos will help us through that. Mr. van der Westhuizen, can you please share your presentation? And over to you. Thank you very much.
Good afternoon, everyone. Can you guys see my presentation at least? Let's just make sure about that.
Yes, we can. Thank you very much.
Fantastic, fantastic. Okay. Yeah, well, it's my pleasure to speak to you all today about structural mass timber engineering in South Africa. My plan for the presentation is to briefly speak to you about my mass timber journey in South Africa for the course of the 3 years of research that I did and the 1 year in industry. Along the way, I've had the opportunity to collaborate with several South African timber industry leaders and really get involved in some fantastic projects, as you can see there. The projects that Bram has shown. I also became aware of some of the current hurdles which the industry is facing from an engineering design perspective and what needs to be done to kind of overcome these hurdles at the end of the day. So just my mass timber journey. For my final year honours research at Stellenbosch University, I investigated the fire resistance of CLT panels manufactured from 2 South African timber species, namely South African pine and eucalyptus. The research went very well, and the South African CLT panels performed well in the fire tests. And I was lucky enough to be invited to Growth Point's annual Greenovate competition, where we presented our research to a panel. Now, I quickly became aware that the panelists weren't really so much concerned about how well the CLT panels burned, or actually how well they didn't burn, but they were more concerned about the supply and the cost of the mass timber. And I realized that there was a real need for research to be done, and research which takes a bit more of a holistic view of the mass timber industry in South Africa. So I'm going to elaborate a bit on that, just because I think there's a topic that we really need to focus on as well, just to make sure everything is feasible. And yeah, so I went on and did my master's research, which focused on the economic viability of mass timber in South Africa. And I decided it was necessary to try and have a look at each aspect in the supply chain of multi-story mass timber buildings in South Africa, right from the supply through to the design and construction thereof. So there, my master's thesis title, the development cost comparison between a multi-story mass timber and reinforced concrete building in South Africa. So for this research, myself and other engineering consultants designed an 8-story commercial mass timber building and a replica 8-story reinforced concrete building, and we did a development cost comparison with the two. There were several stakeholders involved in the research. There you can see a number of the organizations on the right. Range from local and international suppliers to quantity surveyors, local and international engineering consultants, and even property developers, which assisted with the feasibility study. Their contribution really allowed for the scope of the research to be increased and in effect made the research much more relevant. So the first thing I had to look at when I entered the research was, is the supply of timber in SA actually enough to sustain a multi-story mass timber market? Now, in terms of supply, I'm not an expert in this, and I really relied heavily on Dr. Brian Vessel's research, and he's on the panel today. And I would, all the questions that we have regarding supply and so on, I would say let's keep them for later on in the discussion. The long and short of it is, yes, our current timber supply is oversubscribed, but we could have a much more sustainable supply of high quality structural timber. But for this to be achieved, we need more investment into plantations, and our current timber, which is currently exported, needs to be utilized locally. I know some of the suppliers or whatever are in the audience are probably have lots of questions at this stage, but I'll just hold on and then we can ask them at the end. So to get on to the design of the building, which is what the brunt of the research was actually about. There on the right you can see the 8-story commercial mass timber building with a glulam beam column frame and single spanning CLT floor system. So what I found difficult at the start was to decide which code to use. Bram alluded to it earlier. Yes, we have SANS 10163-1, which is perfectly fine for designing structural timber elements, but it doesn't really deal with the design of CLT. I therefore decided to use the Eurocode 5 for the design of the mass timber structure, with assistance from various software packages, free software packages, which such as Stora Enso's Calculatus software and Rothelblas's Steel Connection Designer. But just to clarify, the idea that we can't design mass timber structures in South Africa is nonsense. It's not that we can't, it's more of a case that we don't have experience. Chris Greensmith from 7x6 still said it well in his iStruct presentation a few months ago. He said a force is still a force, a load path is still a load path. These principles remain the same irrespective of the building system, whether concrete, steel, or timber. And this is something that we need to realize. It's also the reason why I'm not going to go too much into the technical details of the design, because one, it gets boring, and I don't think our audience wants to be bored. And two, it is in a sense very similar to your other design systems, and I think it's something that we can discuss further in further webinars. So there are different codes that we can look at. Canadian code, for instance, American code, the Eurocode, which we could use to design for CLT. I don't want to dive too deeply into the various analytical methods for calculating member capacities, but I think I should just mention them for the structural engineers that are on the webinar, just to find a path to help them design with CLT. And they're the 4 main ones, namely the gamma method, the K method, the shear analogy method, and the Timoshenko beam theory. Bram Wessels will also have a bit to say about the gamma method and the shear analogy method. So Stora Enso's Calculatus software, which is the software I used to design my CLT floor system, uses the shear analogy method for the calculation of the bending resistances for the CLT products. Eurocode 5 Annexure B allows for the gamma method to be applied, while the American code and the Canadian code use the shear analogy method as well. Okay, hopefully that's all of the boring stuff behind us. For my specific research, I used the SANS loading code, which is that's SANS 10160, which is actually compatible with all the Eurocodes. And but I used, like I said, the Eurocode for the design of the timber structure. So some design aspects to consider. Apart from the code, the next thing to consider was what material sizes were available in SA. Before I go on, the building on the right isn't the building which I designed. That is just the Brox Commons building. It just shows you a different structural system which can be used. If I go back to the previous slide, you'll see, I don't want to get too complex here, but the lateral stability in this system is provided by, in this case, a CLT core, and as well as this horizontal bracing system. In the Brox Commons building, it was actually a concrete core, which provided the lateral stability, and but all of the remaining was mass timber elements. So to get back onto the availability of material sizes, it became apparent to me that this sort of information should be easily accessible for every structural engineer by the push of a button, and something which should be worked on, because I couldn't find any, can I say, standardized material sizes available. Unfortunately, for my research, I had to phone countless different suppliers to find out what mass timber size they can manufacture. And when it came to modeling these elements, it also became apparent that suppliers didn't really have digital models or BIM families, as we could call them, to make the modeling much easier. And this is something Bram also touched on earlier. I also realized that our manufacturers don't have presses large enough to manufacture the mass timber sizes required for this sort of building, which I designed. Now, from our industry side, we can't blame the manufacturers because there has never been a need to manufacture such large elements. So why invest in such large presses? I still listened to a presentation by Dr. Brand Wessels, and he said it's a case of what comes first, the chicken or the egg. So, but I do feel there's definitely a growing demand for large structural mass timber elements to be manufactured, and that manufacturers, with the support from government, need to seriously consider investing in larger presses. So something that the architects are also aware of, and that's going on to my next point, is the column spacing is quite different for a mass timber building as what it would be for a concrete or steel building. The reason being that we don't want to span too far with the CLT floors, and we generally try and limit them to 6 meters for commercial spaces, and that would typically be a 300 thick CLT slab, 3 by 6. So we'll have a 6 by 9 column grid spacing typically. Also, the mass timber needs to be transportable, which is a very important aspect. So we need to make the member sizes as practical as possible to fit into a container, which is why we go with the 6 meter, 6 and 6 can give you 12, and then it'll fit in that container. Another issue which I only became aware of while in industry is actually allowing for sufficient time for procurement of the mass timber elements, and if they are to be imported. Currently, there's a massive international demand for mass timber elements. So if you want to procure these elements from big international suppliers, you need to get in your order as soon as possible to prevent delays in the project. This is actually some issues that we have experienced in projects that we're working on. Moving on to the treatment of timber, I conducted an interview with a SAWPA representative in my thesis to find out more about the treatment, as it has been quite a contentious topic for some time. SANS 1005, I think, specifies that timber used in the erection of buildings within the coastal zone of SA needs to be treated for termites and wood borers and fungal decay. In other words, timber above ground in the coastal areas need to be treated to H3 hazard class, which is copper-based waterborne preservative. Generally, imported mass timber is untreated, making it unsuitable to use as a structural building material within coastal zones unless treated afterwards. Now, this treatment, this preservative treatment by pressure impregnation, cannot be applied successfully to spruce, which is one of the most popular species generally imported. Now, you can imagine that this causes all sorts of headaches, but I believe we'll be having another discussion on this in a webinar to follow. So let's just park it for there, and then I think it's Bruce Breed from SAWPA is also potentially having a discussion with us regarding that. So just to move on from that, I've listed here acoustics, vibration, fire as additional aspects to consider while designing. And the MC alluded earlier that I'll be talking about these common, can I say, misconceptions of timber. I'm actually not even going to talk about them because it is misconceptions. And this first webinar is actually just a quick introduction, can I say. But there's tons of information on that. And I urge everyone to go have a read on that. But the long and short of it is that there are solutions for all of these different design considerations. Each building system, whether steel, concrete, or timber, has areas which need more attention than others. That doesn't mean we shouldn't be designing with it. Whether it's acoustics, which basically, for those of you who don't know, it's soundproof and so on, fire or vibrations in the floor, we can successfully design for it, and it has been shown internationally that there are more than enough buildings that are built according to regulations and standards. So just for interest's sake, that was the design aspect of my research. Then we went on to actually the feasibility study, the costing, and so on. I added this just to the presentation, just for those that may find it interesting. The mass timber building, you guys can see here, the construction schedule was reduced by 50%. We had a focus group workshop with project managers and contractors and manufacturers that assisted with the construction schedules for both of those, the mass timber and the reinforced concrete building. The total capital investment for the 8-story commercial mass timber building was 115 million, which was 10% more than the reinforced concrete building. This can be expected because it's a more expensive material here in South Africa. And then the thing that was, can I say, was quite important to have a look at was the 5-year internal rate of return, because internal rate of return takes into account the time value of money. And as you'd see, even though we managed to reduce the construction schedule by up to 50%, the 5-year IRR of the reinforced concrete was still better than that of the mass timber building. We did do a sensitivity analysis, playing around with rental rates, P&G costs, accelerated timeframes, and so on. And we actually found one of the most significant findings out of that was that a rental premium of 7.8% or more results in a higher 5-year IRR than that of the concrete building.
Fanny?
Yes?
Could you please wrap up just for the purposes of time? Thanks.
Yes, okay. So just, that was actually my last remark anyway. So from our side, we need experience. That's the main thing. It's not design that's the issue. We need to get experience from manufacturers, designers, quantity surveyors, contractors, the entire project team. That's the main hurdle that we need to overcome. Change perceptions in South Africa regarding timber, quality supply of high-grade structural mass timber, and lastly, we need the collaboration and support of all sectors, academia, public, private, everyone. Thank you.
Thank you so much, Fanny. For the purposes of time, colleagues, can I hand over to Prof. Brand to take us through the third one? And I would request that colleagues we be mindful of the time. Thank you. Prof. Wessels, is it possible that you could put it on presentation mode? It's slightly small.
Is that better?
You're there now.
Yes, indeed. Thank you.
Good afternoon. I just want to give you a quick overview of research done in South Africa to support building of mass timber structures as well as the manufacturing of mass timber components in South Africa. The first topic I want to discuss is that of the quality of structurally graded timber in South Africa. Now, the quality of mass timber products is to a large extent dependent on the quality of the structural lumber from which it was manufactured. In 2011, a project was started to develop a quality assurance system for all lumber graders in South Africa. The sawmilling industry was represented by Sawmilling SA. They were involved in that. Lumber auditing bodies such as SABS and SATAS was involved with the project. Our own university was involved with that, and a quality assurance standard was developed. You can see the picture here, the SAS 1783 Part 5 standard. This standard requires lumber graders to continually test subsamples of their production on a machine like the one you can see in this picture. This makes South Africa one of only 2 countries in the world that requires such continual testing of lumber, and it makes us probably one of the countries with the safest graded structural lumber production systems in the world. A very important development for prospective CLT manufacturers in South Africa was the development of a CLT standard for South Africa, and that standard came out in 2020. It was basically an adoption of the American standard for CLT. What we did was just replacing all the American specific content with South African content to make it fit for purpose for South African users of the standard. When engineers design a structure from CLT, they will of course need strength and stiffness values of the CLT to do the design. You can see a table of the Canadian design values at the bottom right here. We started a project in 2019 to develop such a table for SA Pine CLT. It was part of a master study of a student. It consists of 2 parts. Firstly, a large-scale testing program where CLT was manufactured and tested, lots of different layups and quality. And then the second part is to use modeling, use the input values from South African structural lumber and to model the strength and stiffness of the CLT, and then to identify the most accurate modeling approach. And lastly, we will develop design tables such as this one that you can see, so that South African engineers can have a table to design it with our own local timber. Timber used for structures in some parts of South Africa, the coastal areas, need to be treated when used in structures. For mass timber, it can be a problem because these components are usually quite big and you cannot treat it after manufacturing. So you must treat the laminates before you glue it together, and there can be an influence of the treatment on the bonding process. So we did a couple of projects to test whether certain preservatives and adhesive systems can be used for mass timber. We did it for both South African pine and eucalyptus, and for most of these combinations we did get acceptable bonds. So we can produce treated CLT, for instance. The only CLT manufacturer in South Africa, XLAM from Cape Town, in fact use a different preservative, Vaxol Azure, with polyurethane adhesive, and also get acceptable results. So it seems like durability treatments are not a problem for mass timber, and there are various options that manufacturers can follow to get treated CLT. Mass timber generally have very predictable fire behavior, so it's easy to design buildings for fire when using mass timber. But there's always a perception that wood is a problem with fire. We've been doing a couple of projects in cooperation with the Fire Engineering Research Unit at Civil Engineering, Prof. Richard Wall's unit. On fire, there was, for instance, a couple of years ago, I think Fanie van der Westhuizen was involved with it, study to determine the charring rate of SA Pine and eucalyptus. Currently, we also have projects on different things that you can use to improve fire behavior, for instance, which adhesives to use and whether you can treat it with fire retardant. But important thing is the information is available for engineers to do design for fire of mass timber using South African resources. The model for manufacturing CLT in Europe and the USA is the CLT plants are usually separate entities from sawmilling. I think in South Africa, if we want to consider a lower cost model, it will have to be integrated sawmill CLT manufacturing. If we do consider it, I think there's a host of opportunities to lower the cost of CLT, for instance, including various defects, random widths in CLT. Our initial estimations is that sawmills can improve the volume recovery with something like 10%, which is a huge amount. One can consider the potential of processing some parts of CLT green, and also another thing that we've been looking at is the use of young eucalyptus as CLT. So as long as we don't go with a European and a American model of CLT manufacturing, I think there's a lot of potential for reducing cost of CLT in South Africa. In conclusion then, I think firstly, the basic research and knowledge for locally manufactured mass timber is available. Secondly, I think there's a potential for South Africa to play a unique role in CLT manufacturing and from plantation resources, and maybe even become a leader in that. And then finally, the main hurdle is we need a local CLT demand, and that's of course also why we have this webinar. Thank you.
Thank you so much, Prof. Wessels. And I think, colleagues, now we are at that time where I hand over to Dr. Skalk-Grobler to lead a few questions to those presenters who had an opportunity to present for us. Thank you.
Good afternoon, all. Thank you for the opportunity to ask a couple of questions. So all of these questions that we'll ask, if we have time, will be to the panel in general, but the specialists are welcome to answer the questions. So I think the first question is that if we were able to increase the demand for mass timber in South Africa, would we be able to supply the raw material for an increase in the demand?
Skull, can I take that one?
Yes, you're welcome.
Okay, so yeah, I think Fani also talked about this. In South Africa, we do have enough softwood timber to supply this demand at the moment. I don't think it's oversubscribed at all. But for the future, actually the short-term future, there are also opportunities. We, for instance, export quite a lot of eucalyptus chips, and what we need to do is to get the processing capabilities to process that profitably, and then there's actually quite a huge reserve that we can delve into. So I think the short answer is we can, on a relatively short time period, if we put our minds to it, we can supply a huge increase in demand in timber. Longer term, of course, we'll need some extra plantings.
Okay, that's good to hear. Then, Dr. Mareri, I think this question is specifically for you. So to develop the market for mass timber in South Africa will require collaboration between the public and the private sector. How do you think the private sector can assist the public sector with increasing the adoption of mass timber construction?
Thanks, Chairperson and Moderator, and good afternoon to our audience. I think there are two major things. The first one is that in terms of the public sector in dealing with the state and timber, we consider timber under innovative building technologies. So the first thing that we do under innovation is that we invest in changing the mind shift of the public, especially where we serve our clients. That means that we want the users to understand that if we are dealing with houses that are constructed with timber or a lot of timber elements, they're not of a substandard quality than those that are constructed using brick and mortar. The second aspect is in terms of the partnerships with private sector. Private sector needs to understand in detail that when dealing with the state in terms of timber and its consumption for construction is that it's a long-term investment. The moment private sector hikes the prices to try and get a profit out of that immediately, you find that then it's out of the subsidy quantum, and therefore the state cannot absorb the quotations under the tender processes. So we also need private sector to work with us, especially in terms of costing. The third one is in terms of the use of the technologies like the first presenter did in terms of 3D printing and so on. I think if we can break the barriers in terms of technology communication, in terms of the way timber is used in construction, the available scientific methods, the testing, the flexibility, the advantages, also to show things that like the fireproof of the treated timbers and so on. I think that would go a long way in increasing what we call the scaling up of the use of timber in government-led projects. Thank you, Chairperson.
Thank you very much for that reply. Before we go to some of the questions, I think some of the questions from the members would actually be good to answer in the next webinar, especially the one regarding the banks, so that we should definitely address at the next webinar and also include some of the banks into that meeting. So I think the $1 million question to the panel is, what should we do to increase the adoption of mass timber construction in South Africa?
Scott, should I go first?
Yes, you may.
All right, thanks. I think the first one is the education of professionals, my own colleagues, architects, our colleagues, the engineers. I think there's a huge opportunity for the two universities, and I know NMU has also got a very strong timber department that they develop short courses for professionals to understand the intricacies of the material and how do you design for it. I think there's we need to also invest in education of carpenters and skilled construction workers, construction managers in the use of timber. Again, I think it can be done with short courses through the universities and institutes, and then also establishing and trying to support, augment the manufacturing facilities, the few that we have, with funding maybe from government itself, or private funding to set up larger press factories or presses in factories to produce CLT. Thank you.
Thank you. Brand, do you have some inputs on this?
Yeah, I think Schalk, you put me on the spot there. Yeah, I think actually something like this webinar and just getting a general awareness of the potential of mass timber will be crucial, because we don't have this industry. There's nobody actually driving it. It's something that must be created. And what the DTIC is doing here, for instance, doing these type of webinars, also us as universities and the other ones involved with wood, we've got a responsibility to try to reach out and educate people that's already in industry, not just new people coming for taking degrees with us. Yeah, that's my take on it.
Skalk, if I may add,
yes.
I also think there's also a need for potential pilot projects and so on to come on. With these pilot projects, we can use it as learning opportunities for carpenters, for designers, for architects, and so on. Wood is very much a material that you need to see, you need to work with it, And so I fully agree with the training, but one step further is to do these pilot projects, and for that we need funding from private sector, public sector. I think that'll be a good step in the right direction.
Thank you. Dr. Marembe, do you have some inputs on this question?
Thanks, Chair. Just the same thing, same campaign I just indicated earlier, and that is awareness to the consumer, awareness to private sector, and then more publicity about what's possible in science with timber. Because once the public is aware what timber can do and how safe timber is, then in that way, consumption, then there's a market, not just in the public, not just by government, but also in the public sector. So for me, it's awareness campaigns, but also the knowledge on how the whole procurement value chain works with government. Thank you.
Thank you. Then, Professors, you did indicate it in your presentation, but maybe you can just elaborate a bit more. Are there alternative wood-based materials that could be developed and used in the South African context specifically? So, in general, we are familiar with the CLT products that are produced in Europe and mostly North America, but maybe there are some products that we can develop specifically for a South African context. Do you have some inputs on this?
Yes, I think actually the biggest potential probably for wood in South Africa will be on the residential market, and CLT is it's used for residential housing as well, but it's often a bit of a high cost one for residential market. So I would say timber frame building, and there are lots of developments on how to get factory built housing going. Like CLT, the problem is again, you need a market to develop the manufacturing capability. So it's always this chicken egg type of thing. But so we'll probably have to slowly increase our use of timber, and then the manufacturers can scale and drive down costs. But I would say, in my opinion, residential housing is probably the main opportunity, and CLT might not be the biggest product in that space. So a panel type of products, but maybe a lower wood content.
Okay, thank you. Then Brand, I'm gonna run this question to you as well. So this is one of the questions from the participants, and it's regarding the life cycle cost of mass timber buildings. The question is, how does that relate to all, let's say, general buildings like concrete? Do you have an idea or some inputs on that?
Yeah, Skalk, unfortunately, no, not hard data on that, what the life cycle cost will be. I can maybe pass it on to Fani again. He's done some costing study on the life cycle costing. Yeah, so unfortunately not much from my side there.
No, thank you, Brand. Fani, you're welcome to fill that one.
Skalk, if I had to do my PhD, I'd do that one now. Exactly. That's that. No, it's a
good idea to do that.
Yeah, there's quite a few studies on it, but to be quite honest, I don't want to elaborate on the topic that I'm not an expert on. So I think it's something that we can maybe research and touch on in the next webinar briefly.
Okay, thank you very much. Yeah, I think we're almost at the end of the session, so I'll hand over back to Brock Yu, the MC. Thank you to the panel for answering the questions.
Thanks very much, Skalk. Colleagues, without further ado, I think I would like to put Sam on the spot about the survey link that we have. Have you posted it, Sam, before I hand over to Roy to do the closing remarks?
It is now live. I've put it on the chat. Thanks, Brock Yu.
Okay, thank you, colleagues. Take note of that link for some level of survey, and we would like to have your feedback. Colleagues, this is the last word you hear from me. Thanks for allowing me. After the Roy I won't be talking anymore. We don't usually talk after the elders have spoken. Over to you, Roy. Thank you so much.
Thank you, Brock, and good afternoon to everybody. It just falls on me just to say thank you to you all for attending. Thank you to the speakers for participating, and thank you very much to Sam for facilitating and organizing the program. I think we've learned a lot from today. Timing is an issue. The correct platform will be an issue. There are a number of lessons to be taken from this, and so it's been very productive in that respect. And then I think just a great thank you to all the speakers, to Bram, Stefanos, and Brandt, the experts, the so-called experts. Well done, guys. And to the people who have been fielding questions and answering, doing all the background work, Dr. Jennifer Marembe, Professor Krishna Duplessis, Tafadzwa, who, if I remember correctly, will soon be Dr. Tafadzwa Nyanzinda. She's on her way in that direction. Of course, to Skalk, Dr. Skalk Grobler from University of Pretoria for his input. And I've mentioned Sam, so thank you very much, Sam, for putting it all together. And I think that we just need to take stock of where we are, and there are lots and lots of questions, and this is a very broad topic that's going to require many more of these webinars to answer all the questions, and so there'll be a lot more coming up, and that's the future. And so we'll take all these, all your questions and all the things that we've learned from you, and we'll push it up into the future. One point that as a sawmiller I need to just mention here, you will have seen that my association, Sawmilling South Africa, are the headline sponsor of this webinar, and that is because we have a vested interest here. Just about all the products that we've been talking about, the mass timber products, things like plywood, CLT, all the rest of them, all start at the sawmill. And so we have a vested interest, and that's why we're involved and why we're pushing this. And to answer the question about will there be enough resource, well, we've heard from Dr. Brandt Wessels that we could increase the productivity at or the recovery at sawmills by somewhere in the region of 10% if we start to produce or manufacture these more sophisticated products. And if you just think that there's give or take 2 million cubic meters coming out of the sawmilling industry in South Africa at the moment, a 10% increase would push that up by 200,000 cubic meters, which would go a really long way to making sure that there's enough material. So the sky's the limit. There's a lot to be done, and we're on our way to get there with the help of all you people that have kindly participated today. Thank you to you all, and goodbye.